Welcome to my channel. Your tutor Mariam is here. It's a 52nd video of Introductory Physics 1 and a 14th video. I'm going to talk about the laws of motion. That is the fifth subject of Introductory Physics 1. In this video, I'm going to talk about the concept of the friction, and in the next videos, I'm going to solve examples. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. The first question is, what is a friction? Friction is a resistance of the object. Imagine I try to pull or push the box, and if the box is heavy, I can't push it, right? So that's resistance called the force of friction. This resistance always exists, but if box is heavy, I can feel it better, right? So there are two forces of the friction: the force of static friction and the force of kinetic friction. Let me break it down for you. Let's say I have a box right here with a mass of m, right? If I'm on the earth, gravity always apply, right? So the forces applied to this box are gonna be the force of gravity, which we show it as W. It's m times g, right? Mass times acceleration. They're gonna be normal force, that is gonna be upward, right? The direction of the normal force is always opposite the direction of the surface. Let me draw the surface here. And then if I push the box, there's gonna be another force. This is a force I'm applying, right? So the friction force gonna be the opposite side of the force I'm applying, and can be Fs or Fk. S stands for static and M stands for the kinetic friction. Okay? And again, I'm gonna emphasize that I'm on the earth. Okay, so gravity always applies. We're solving the physics equation on the earth, so we do have a gravity. Now let me talk about the force of a static friction. Let's say I apply a force, but this box never move. Okay, that force doesn't allow me to move the box, called force of a static friction. So this is Fs, and then it's going to be equal to mu s times n. N is the normal force. It's the same force as we consider here. That's a static force is always going to be equal or less than the force I'm applying here. Let's say I'm going to call it Fj. So this is going to be always a smaller or equal to Fj. Let's say I'm getting to the point that mu Sn is equal to Fj. The force I'm applying is equal to a static force, then object start to move, right? And this is a condition it happens. So now let me talk about the force of kinetic friction. Now my object starts to move, right? Now I have a kinetic friction. So my kinetic friction Fk is equal to mu k times n. And this is a point my object start moving. So in summary, if your object is at rest and is not moving at all, you need to apply Fs or a static friction, and it's always less than the force you apply. As soon as your object starts to move, then you have a force of kinetic friction, and then that kinetic force is equal to mu k times n. Sometimes in your exam or your homeworks, you see the problem gives you both of them, mu s and mu k. So be careful here about the meaning of mu s and mu k. Now let me solve a simple example for you to make it more clear. So here I have a box with a mass of 2 kilograms, is at a rest on the horizontal surface. What is the minimum force required to box moves if the coefficient of static friction is 0.3? So here it doesn't mention which direction box gonna moves. So there are two options, right? So if the box is right here and object move in this way, let's say this is Fj, then friction force can be this way, right? Because this is a resistant and it's always going to be the opposite direction of moving the box. The other possibility is like there is a box right here and box is moving this way. That's going to be my Fj, right? Then my friction gonna be this way, right? So that's gonna be Fs for both, right? So let me write down the equation. My Fs gonna be equal to mu s times n, right? And n is my normal force. So my normal force gonna be upward and W gonna be here. It's gonna be mg, correct? So let me calculate the normal force first. So based on the second Newton law, I have the net force as the sum of the force applying to the object. So it's going to be N minus mg, right? Because normal force is upward, mg is downward, and there is no movement on the vertical direction. So that's going to be ma, but that's going to be 0, right? Because there is no movement and acceleration going to be 0. So based on that, my N is equal to mg. My mass is 2 kilograms. G, I'm going to assume this is 10. Usually it's 9.8, but for simplicity, I'm going to assume it as 10. So it's going to be 20 newtons, right? This is the units. That's the symbol. Be careful about these two. So now I have N and mu s. So my Fs gonna be equal to my mu here is 0.3 times 20, correct? So that's gonna be 6 newtons. So that means if I apply 6 newtons to this box start to move. So if I wanna move the box, force should be more than 6. I hope you find this video helpful. If you like my video, hit the like button and subscribe, and I'll see you in the next video.